let's talk about linear equations. So a linear equation is just some expression with a variable on its own. So something like 2x plus 5 equals 13. So we want to solve for x in this equation so that the equation becomes true. We want to figure out what x can we plug in to make this equation true. So the way to solve linear equations is you can do the same thing to both sides. You can add or subtract the same thing to both sides. You can multiply or divide the same thing to both sides. So here it's always a good idea to try to isolate the variable. Try to get the variable term alone on its own side. First, don't worry about the number that's multiplying it. We'll take care of that later. But just try to move all the other terms to the other side. So like here this minus 5 is kind of in the way. So let's move it to the other side. By move it, I mean let's subtract 5 from both sides of the equation, and then we get 2x plus 5 minus 5 equals 13 minus 5. So minus 5 plus 5 minus 5, this cancels out. That becomes 0. And then this becomes 8. So we've got 2x equals 8. And then we can divide both sides by 2 to turn this into just x by itself. Like, because 2 divided by 2, that's going to be 1x, which is the same thing as x. And divide this side by 2 also, because you got to do the same thing to both sides. 8 divided by 2 is 4, so x equals 4. And we can plug it back in to check. We can do 2 times 4 plus 5. If we've got the right answer here, then it should come out to 13. So that's what it needs to be in order for the equation to be true. So 2 times 4, that's 8, and then plus 5. Well, we did it right because that's 13. Great. Let's do one more. How about something like, let's make this a tricky one. What if we make this like 2x plus a half equals 1/3 plus 5x. So I think whenever we have fractions, it's easy to multiply both sides of the equation by something that'll cancel out the fractions. So let's multiply by 2 first to cancel out this fraction, and then we'll multiply by 3 to cancel out that fraction. So really, if we're multiplying by 2 and then multiplying by 3, we're just multiplying by 6 in all. So let's times 6 to both sides. Maybe instead of writing x6, I should write dot 6 so you're not confused. Times 6 to both sides. Well, 2 times 6 is 12, so 12x, plus a half times 6 is 3, equals 1/3 times 6 is 2, and then 5x times 6 is 30x. So now we've got no more fractions, got nice whole numbers. Now it's time to isolate the variable. So let's try to get the variable over on one side. So maybe we usually like to solve for the variable on the left hand side. You could also do it on the right hand side, but just for the sake of example, since I also want to show what happens when you get a negative number on the x, let's minus 30x from both sides to get it on this side. So minus 30x minus 30x. 12x minus 30x is minus 18x plus 3 equals 2. And then let's minus 3 to both sides. I'm running out of room, so I'm not going to write down the minus 3. Just going to write minus 18x equals negative 1, because that's what you get when you minus 3 from both sides. And then now we can divide both sides by negative 18, or maybe it's easier to think about. I'm just going to write up here. Multiply both sides by negative 1, then you've got 18x equals 1, and then divide both sides by 18. You've got x equals 1 divided by 18. And when we plug that in, that should work. I guess this is kind of a nasty equation to check, but let's do it anyway. So 2x, that's 2 over 18, plus 1/2 is like 9 over 18, equals, well, 1/3 is like 6 out of 18, and plus 5 out of 18, because x is 1 over 18, and we're multiplying that by 5. So 11 out of 18 equals 11 out of 18. Yeah, it checks out, matches up. Good.